All right, number 37A. So we have to draw the battery. And so first they give us the equation. So we need to identify who's the oxidation, who's the reduction. Okay. So the oxidation of the chlorine is -1, the oxygen is -2, 14 plus 6. Elements are 0, and the chromium would be +3, because ions have the same oxidation as their charge. So the chromium is being oxidized, and the chlorine is being reduced. So now we can draw our battery. Okay. It doesn't matter which one you make the oxidation, which one you make the reduction. I'll just put the anode here. So if this is the anode, that means this is going to contain the oxidation. So that would be chromium 3 plus. Put our water in there, chromium 3 plus, aqueous, and our chromium 027, 2 minus, aqueous. Okay. Over here, we've got our reduction. Okay. So this is going to be the cathode. Electrons always flow from anode to cathode. So obviously we can't make an electrode out of chlorine or chromium, so we can pick whatever you want. We could pick 2 platinum ones. The salt, sodium nitrate, is always a good one. So I'm just going to write out my reaction here, my half reaction. So this is going to have to take 2 electrons. So that means the electrons are going to be flowing into here. So if the electrons are flowing into here, it means that the sodium is going to migrate to this side because that's where the electrons are going. Here the electrons are going into the electrode, so the nitrate is going to migrate over there. Okay? And that's all we had to do. Oh, I guess we have to give it overall balanced reaction. Oh, shoot. So let's quickly do the overall balanced reaction. I'll have to do that on the next page. So 2 chromiums there. We're going to need 7 waters to balance out the oxygens, which means 14 hydrogens. And then I've got a charge of plus 20 on this side and minus 1 on that side. So I'm going to need 19 electrons. Oh, wonderful. Okay, and then we've got the chlorine becoming chloride. So I'm just going to need a 2 there. Okay. And so the oxygens are balanced, the hydrogens are balanced. I just have to balance my electrons. And I must have done something wrong. What did I do wrong? Oh, that's what I did wrong. This charge is a 2 minus. Okay. So my 2 chromiums. Got 7 oxygens, 14 hydrogens, 14 hydrogens. So that means I'm going to need this is why you shouldn't do chemistry late at night. I need 2 electrons here, obviously, to balance this out. Okay? Why do I have the charge on the wrong side here? +3. Maybe I shouldn't have tried to balance this, and it seems like my computer froze here. Okay, there we go. 7, 14. Oh, jeez, there we go. I'm too tired. I need my 7 waters on this side. Oh boy. And you're all probably at home going, of course, I know what to do. So there you go, and then we have to add my, now I get to add my electrons. So I got 6 on this side, a positive 6 on this side, and I got a positive 12 on this side, so I'm going to need 6 electrons to balance it out. So now I've got electrons on the opposite side. I multiply this one by 3, so that's going to give me 6 electrons, 3 chlorines, and 6 chlorides. Okay. Now we can add it up. All right. It's balanced. Now, if we were going to do the shorthand notation, why can't I go up? Well, you go from anode to cathode for shorthand notation. So on the anode side, I had platinum electrode, and then the chromium 3 plus was aqueous, and the chromium C2O7 was aqueous. Then I had my salt bridge, and then I had chloride, but then I draw another line because my chlorine gas is a different phase. And then I draw my cathode. Okay, so that's the shorthand notation. I know they didn't ask for it, but that's what it is.